Hello and welcome to Cadence Design Systems Fidelity Tutorial Tuesday, where we show you how to use a feature or demonstrated technique in just a few minutes.
Today, we are going to look at some basic operations in Surfer and how we can utilize these operations in the Connect app. In the previous video in this series, we talked about how to install and configure the Connect app. Today, we are going to be using the version where we use the Connect app on the same local machine. To begin, we are first going to open the CharLES Connect app. To open it, I'm going to use my alias charles_connect to open the app. For now, we are going to minimize this because we have nothing running yet. So we are going to go back to the terminal and go to a different terminal. You can open a new terminal. Then from here, I'm going to use a few SBN files for this tutorial. And these can be downloaded from the Cadence Online support under the Fidelity CharLES portal. There are a number of ways we can load the geometry into Surfer. The first one is via an input file. So we can create such input file here, say surfer.input, and then we can use serve sbin. Then the path here for now is in the same directory, and queen.sbin. Then we can add an I, or we can do interactive to pause the script here so we can visualize it in the Connect app. So that if you want to load this geometry in, you can do Cascade, which is my alias for the path to the CharLES launch script. Then you type surfer.exe-i, then the script that we just did, and hit enter, and it's going to load. And then we can now go down to our Connect app, and then hit refresh. Then we can see our activity here. So we can now go into 3D app and then visualize our geometry here. I'm going to exit out of this one and then go back to the terminal, and then we can Control C to quit out of this, and then we are going to look at how to load it a different approach. The next way we can also load the same geometry here is, let me clear the terminal, is to use the command line approach. So basically you can do Cascade surfer.exe, then -- serve sbin, then queen.sbin. They are going to put -- I to pause the surfer at that location here. One point to note is that we can actually load, instead of sbin, we can load stl, we can load obj in here, and then we can actually just parse that obj or stl in here, and then we can also visualize it that way. So I'm going to hit enter, and then it's going to load the same geometry again, and then we can go into our software. We're going to refresh it, and then the new one a few seconds ago. Then we can go into the 3D app and visualize the geometry here. A few points to note about the coloring of the geometry here. If you see gold on the outside here, this means that the fluid is not touching the geometry. And if you see silver, that means that the fluid is touching that geometry, and hence a mesh is going to be generated in that region here. So in the likely situation where you want to mesh or generate a mesh around this geometry for an external flow type simulation, you can go into this center, the zones, you can select these geometries here, and then you can go to Surfer, Facet Repairs, and then Flip Selected. Flip the normals, and now when you go to unselect them, you can see that the normals are flipped, and now the fluid is touching the external surface. If you intend to do the internal flow simulation here, you can flip the same thing and then kind of get the gold outside and the silver inside. Surfer is a discrete surface manipulation tool. It was designed to be a simple preprocessor for our mesh generator stage to ensure the quality of the surfaces passed into stage are sufficient to generate a valid volume mesh. We're going to look at some basic operations we can perform in Surfer. First, we can go into Views and then select Mesh, and we can look at a surface tessellation of the geometry here. You can always turn it off by going back here to View and Mesh again, and then you can take it off. Again, in Views, we can actually go in here and then select Blanking, and we can select the orientation of the blanking, so X, Y, Z, and then we can hit OK, and we can actually do a plane cut so you can see inside the geometry. And when you are satisfied with that, you can hit delete and it updates in real time, and you can close that and you get back our full geometry here. So now for the purposes of this tutorial, I'm going to go back and select them and flip the normals back to the original. Then after that, we can actually do some diagnostics of this geometry here. So you can look for open edges by going to views, edges, and it's going to highlight in blue all the open edges of the geometry here. So you can inspect the geometry to make sure that there is no unwanted open edges anywhere on the surface here. One nice feature of Surfer is the ability to split a zone into subzones so that eventually we can apply specific boundary conditions to these subzones or local refinement windows in Stitch. So here we are going to select the wall subzone and we are going to go into Surfer, Zone Operations, Split Selection by Crease Angle to split this selection into its subzones based on the feature edge angle. So we are using the default feature edge angle of 150 degrees. This feature edge angle can also be updated in Surfer settings, and then the crease angle you can update it here. Now after the decimation of that subzone has been completed, you can actually just go here and select, to look at all the geometries that have been split in here. So let's just say I want just the bottom cap of this chest piece to be a different subzone. I just want to go here, right click, clear selection, rotate it, and then select here, and let's say here for these two subzones, and then I can right click here, go down to move to zone, and then maybe say chest piece bottom, and hit apply, and now we have a subzone here, chest piece bottom. In future videos, we are going to talk about some additional capabilities of Surfer, as well as some advanced operations that we can do in Surfer to make primitive shapes, as well as geometry cleanup and diagnostics. If you like this video, be sure to click the thumbs up button and subscribe to our channel for more videos like this. If you have any questions, comments, and suggestions, drop us a line below or connect with us via LinkedIn, which is linked below. Thank you all and have a pleasant Tuesday.